When we picture the birth of modern chemistry, we usually imagine a scene like this, a Renaissance study where scholars are supposedly the first to categorize the properties of the physical world. But that version of history is late by several centuries. The foundation for chemical science was actually built over 1,200 years ago in the laboratories of the early Islamic Golden Age. For generations, European scholars relied on the writings of a figure they called Jabir. In reality, that name belonged to the 8th century polymath Jabir ibn Hayyan. Jabir reached a conclusion that his predecessors missed, that the nature of matter cannot be found in books or philosophy alone, but must be proven through physical observation. Before Jabir, the study of matter was alchemy, a field where logic was often secondary to mysticism and the pursuit of creating gold from lead. This era was defined by secrecy. Alchemists intentionally hid their methods behind metaphors and coded language so that others couldn't steal their work. Because no one recorded clear steps or shared their failures, knowledge could not grow. Every practitioner was trapped in a cycle of starting over, testing the same theories their ancestors had already disproven. Jabir arrived in 721 CE with a different approach. He argued that the physical world is understood only through physical experimentation, using specific, measurable quantities. By prioritizing what could be seen and measured over what could be imagined, Jabir provided the mechanism for science to finally move beyond speculation. Jabir moved the study of matter out of the mind and onto the workbench, turning chemistry into a physical craft. This diagram illustrates his systematic approach. He refined processes like distillation, crystallization, filtration, evaporation, and sublimation. These methods ensured substances were no longer mystery mixtures. They could be separated, purified, and studied as pure elements. To perform these tasks, he designed specialized equipment, glassware, and tools that are the direct ancestors of modern laboratory gear. These innovations proved that matter followed predictable rules that could be controlled by human intervention rather than magical chance. But Jabir's most significant contribution wasn't a tool, it was a requirement. He realized a successful experiment is worthless if no one else can repeat it. This is the principle of reproducibility. For a discovery to be considered a fact, a complete stranger must follow the same steps and get the same result. This flowchart shows his system. Jabir documented every procedure and observation, allowing for peer verification, which resulted in verified knowledge. By creating this shared record of facts, Jabir allowed scientific progress to build upon itself across generations. This transition from hidden mysticism to a documented system of truth is when chemistry became a science. Long after Jabir's death, his records became the standard for anyone studying the natural world. These Arabic manuscripts were eventually translated into Latin, spreading across Europe where scholars knew him only by the name Jabir. This map shows the pathways of that knowledge. As his translated methods reached European hubs, they provided the experimental framework that supported the scientific shifts of the Middle Ages and the Renaissance. The later European progress in chemistry was built directly on the foundation of this 1,200-year-old methodology. If his influence is so deep, why is the name Jabir ibn Hayyan missing from most modern textbooks? History often focuses on the people who use a system to make a famous discovery, rather than the person who designed the system itself. But his legacy is active in every modern lab. Every time a researcher performs a controlled experiment and records data for verification, they are following the tradition Jabir established in the 8th century. Jabir ibn Hayyan did more than study chemicals. He established the system of documented proof that remains the standard for scientific discovery today.